Can you see my screen?
Yes, I can.
Let's start the chapter periodic table. So this, what you can see on your screen is your periodic table. So we have to learn all the properties, okay, the exceptions. So as if this is a periodic table, so it follows general trends, but there are some exceptions. So we are going to study that. So if I ask you how many blocks are there in the periodic table, what would you answer?
Sorry?
How many blocks are there in the periodic table?
It would be over 100.
No, that is elements. Elements are 118. More than that, but now now it is 118. The last element you can see here is organison. Okay. I'm asking block like S block, P block, D block, and F block. So there are 4 blocks in the periodic table. How many periods are there?
There's 7.
And groups?
18.
There are 18. Okay. So first of all, we'll learn some terms. Then we'll just discuss the trend. So first is your covalent radius. What is the covalent radius? So distance between the two nuclei of the same type of atom. For example, this is also same type of atom. Suppose oxygen. This is also the same type of atom, oxygen. So if you measure the distance between the nucleus of two same type of atom, then you have to just calculate the distance. Suppose this is your D. Then to calculate your R, you just have to divide it by 2 to arrive at the atomic radius. So this is your atomic radius, or you can say single covalent radius. Okay, this is about covalent radius. Write it down.
I'm done.
What is the trend in the period? So atomic radius, it decreases across a period. Why it decreases across a period? Because of the increasingly positive nuclear charge. You can say this is period. Which period is this? 3, right? This is period 3. So increasingly positive nuclear charge, it pulls the outer electrons in the outer shell closer to the nucleus. That's why its atomic radius decreases. Increasingly positive nuclear charge means its atomic number is increasing. Atomic number is increasing. That means the nuclear charge is increasing. And if nuclear charge is increasing, it pulls the electrons closer to the nucleus. So its atomic radius decreases across the period. Okay? Write it down. You don't need to remember, write down the values. You just need to write down the trend that it decreases.
I'm done.
The atoms of noble gases in group 18, such as argon in period 3, they do not have a covalent radius. Why they do not have a covalent radius? Because group 18 elements are unreactive. They are inert. They do not form bonds with each other. But we can determine radius of group 18 elements using van der Waals radius. Okay, so how can we find out the van der Waals radius? By measuring the distance between the nuclei of two neighboring touching atoms which are not chemically bonded together. In the covalent radius, they are bonded, they are into one another, but they are just touching van der Waals radius, like group 18 atoms are just touching, they are not chemically bonded together. So this distance is divided by 2 to give the van der Waals radius. Then this figure will be higher than the single covalent radius of any given element. Why? Because you can see that if you have a covalent bond, then it is something like this, okay, in bonding. But if you have a van der Waals radius, then they are just touching, they are not forming bonds. So obviously your van der Waals radius is higher than the covalent radius. You can, not even here. But yes, this is your covalent radius, which is they are forming bonds. This is covalent radius, and they are just touching each other. They are not forming any bonds. So this is your van der Waals radius. The van der Waals radius, van der Waals radius, the value of van der Waals radius is higher as compared to covalent radius. Okay, write it down. Now across the period, if we see, then across the period, number of protons, as you see that across the period, atomic number increases, number of proton increases, so your nuclear charge will increases, number of electron increases by 1 with each successive element. So the extra electron added to the atoms of each successive element, the shell is same, it occupies the same principal quantum shell. For example, sodium, it is also 2,8,1. Magnesium, it is your 2,8,2. So you can see here also 3 shells are involved, here also 3 shells are involved. Okay, that means principal quantum shell energy level is same here. So shielding effect remains roughly constant. What is shielding effect? Shielding effect means that if your nucleus is present here and electrons are present in the shell. So these inner electrons, they will shield how well they can shield the outer electrons. So the shielding effect remains constant. Why it remains constant? Because number of inner electrons are same. 2,8 here also it is same. Here also 2,8 same. If we talk about the next element, here also 2,8. Okay. So the greater attractive force exerted by the increasing positive nuclear charge on the outer valence electrons pull them in closer to the nucleus. So what is the reason? Basically, reason is the increasing positive nuclear charge. So as the nuclear charge is increasing here, so it is pulling the outer electrons closer towards it. So this reason atomic radius decreases across the period. Okay, write it down.
Done.
So this is the graph of atomic radius, single covalent radii against your atomic number for the elements in period 3. But argon is not included. Why? Because it belongs to group 18, and in group 18 elements we use the van der Waals radius, not the covalent radius. So it is decreasing like this. Okay, so this is the general trend that it is decreasing atomic radius or covalent radius. So ionic radius or atomic radius, it decreases across a period as the positive charge on the ion increases and the negative charge on the ion decreases. Okay, here you can see is done here.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Here, okay. So as the positive charge increases, that means, for example, Na plus, Mg2 plus, as the positive charge is increasing, that means they are losing the electron. Sodium is losing 1 electron, magnesium is losing 2 electrons, and aluminium is losing 3 electrons. So when the positive charge increases, what happens? Ionic radii decreases. Similarly, if you have O2 minus, if you have F minus, that means you are gaining electron. Oxygen is gaining 2 electrons, fluorine is gaining 1 electron. So the atomic radius increases as the negative charge increases. And here the atomic ionic radius increases as the positive charge decreases. Why? Because the increasingly positive nuclear charge, it pulls the electrons in the outer shell closer to the nucleus. In the same period, the negative ions have larger ionic radii than the positive ions. Okay, because they have one more electron shell. Negative means electron is gained. So the outer electrons are further from the nucleus and there is more shielding. Okay, more shielding of the inner electron. So they will shield the outer electron from the positive nuclear charge. Okay, so if I ask you that which is greater, which have larger ionic radii, Na or Na plus, so the answer should be Na. But if I ask you which have greater ionic radii, F minus or S, then answer should be F minus. Okay, write it down.
I'm done.
Okay, so what about their positive reason? The positively charged ions, they have effectively lost their outer shell of electrons. That is the third principal quantum shell or energy level. For example, 2,8,1 for sodium. So when you are making it Na plus, then it is completely losing this outermost electron. For this reason, cations are much smaller than their atoms, and the negatively charged ions, they are larger than their original atoms because each atom will have gained one or more extra electrons into their third principal quantum shell. This increases the repulsion between its electrons, so nuclear charge will remain constant because atomic number will remain same here also and here also. Okay, nuclear charge will remain constant. Number of protons does not change. Only there is a change in number of electrons. But nuclear charge in nucleus we have protons, so that's why nuclear charge remains constant. So this increases the size of any ion compared with its atom, an ion. So that's why O2 minus is greater than oxygen, F minus is greater than fluorine. Okay, sulfur 2 minus, it is greater than sulfur. Clear?
Yes.
Write it down.
Done.
Okay, so this is the graph for ionic radii against atomic number for the period 3 elements. So you can see that for cation, as the positive charge is increasing, but atomic ionic radius is decreasing, and as the negative charge is then from Sp phosphorus 3 minus to chlorine minus, it is again increasing. Okay, so this is the trend of ionic radius. So this is your homework question that you have to predict and explain the relative sizes of lithium and fluorine, and these are your 4 questions. So you have to tell which is greater. Write it up. This charge is on the superscript like this. Done.
Yes.
Okay, now let us see about the melting point and electrical conductivity. So electrical conductivity, it increases across the metals of period 3 from sodium to aluminium. Okay, sodium to aluminium is your metal, and after that it drops to silicon, which is described as a semiconductor, whose electrical conductivity is average, and falls even further to the non-metallic insulators, phosphorus and sulfur. So you should remember this line at least. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and then okay. So electrical conductivity, as these all 3 are metals, right? Metals are good conductors of electricity. So if we move across here, then the electrical conductivity increases. But silicon is a semiconductor, so in the semiconductor part, it drops and further even falls to your non-metals because they are poor conductors of electricity. So it falls to phosphorus, sulfur, and chlorine. Okay, write it down. So here you can see the bonding about the bonding that we have sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. The bonding is there all first we are metals, then you have covalent bond. Okay, because they are non-metals. Now if we talk about structure, then they have joint metallic structure. But silicon, we have studied this in chemical bonding. If you remember, it has a joint molecular structure, SiO2. It exists as this. And phosphorus, sulfur, chlorine, argon, these are your simple molecular structure. So they are your non-metal. Okay, are you here?
Yes.
Write it down.